Hello friends, we'll be discussing in this video about Python's mutable versus immutable objects. First, we will be discussing about the relation between variables and the Python objects. So, variable in Python is a reference to an object of a particular class type. So, we'll discuss with an example of how this reference to Python objects changes when you perform arithmetic and assignment operations. Let us take this example, x is equal to 2. So 2 is an integer, x is a reference to an integer object which is holding value 2. So this integer object has an ID that can be seen here. Suppose now if you are performing an assignment operation where you are assigning the value of x to y. So what exactly happens is both x and y would be referencing it to the same integer object with the same ID. So suppose if you are trying to do y is equal to y plus 1, which means you are trying to increment the y. So as y value changes, so it stop referencing it to the same object and it will try to create a new object and it references to that. As you can see here, both x and y has a different ID and both these objects holds different values. So ID of x and y are different. Suppose if you would like to do x is equal to x plus 1 operation. So what happens is as the x value has changed, so x would be referencing to a new object which will hold the value 3. 2 plus 1 is 3. Now x will be referencing to a new object which will hold value 3. As you can observe here, the values of the ID of x previously and now is different. So IDs are taken here just for a reference. It need not be exactly same. So the ID of x got changed. So since it is an integer object, it is behaving in this way. So before we understand how these objects respond or how these objects behave, we need to know a categorization of what objects are mutable and what objects are immutable. Let us see what is mutability and immutability in Python objects. So mutable, which means changeable, or immutable, which means unchangeable. So there are certain objects in Python which are mutable and there are certain objects in Python which are immutable. If you see here, the table enumerates there are certain data types which are mutable like list, set and dictionary, whereas other data types like boolean, integer, float, tuple, string, frozen set are all immutable, which means that immutable means the value which is being held in a particular object will not change. Mutable means there is possibility to change the content of that particular object. So let us see in the future slides with examples how and when the object's value would be changed. And the important thing to remember is all the custom objects, which means that objects which are created or constructed from the classes you have defined are all mutable. So if you have written a class definition and if you have instantiated a object from the class definition, then all those objects are generally mutable. We'll also see an example for it. So let us take an example and analyze how integers and list behave. We have seen earlier integers are immutable and lists are mutable, and let us see with this example. So I have a function here named as list append, and I have outside the function I have the following content. So a is equal to 2. A is referencing to an integer object which is holding value 2, and my list is equal to 3, 4, 5, which means that my list is referencing to the starting value of this list. So in the beginning, a will be referencing to 2 and my list would be referencing to 3, which is the starting value of this list. Now once you call this function list append, So references of my list and A would be passed to fn list and B. So let us see how the changes happen. Let us first focus on just the integer. Since we are referencing since B is referencing similar to A, so A and B will be referencing to an integer object with a certain ID which is holding value 2. And now after passing through this function, we are incrementing B is equal to B plus 1, or we are incrementing B. So within this function, the value of B changes. So when you print B, you will be getting 2. But when you print the same A outside this function, it will still have the value 2. And moreover, since you incremented B, the B will not be referencing to the same object, but it will reference to a different object which will hold value 3. So the object which was created earlier will not be changed because this is an integer object and integer objects are immutable. Whereas if you focus on list, for example, we had my list references to the starting value of this list, which is 3 as shown here, and when you pass reference of my list to fn list, so fn list will also reference to the starting value of this list, which is 3. So now you are doing an append operation. Append is a internal method of list. So you are appending 6 to fn list and you are trying to print that. So when you print fn list, the 6 would be appended to the fn list, and this is what you see it. But important thing to note is my list is also getting modified. Why is it so? Because lists are mutable when they are operated by its own methods. With the same ID, the content is being changed, which is not the case in the integer object. So although my list has not been explicitly changed, since both my list and fn list are referencing to the same object, so if you print the my list content outside the function, you will see the changes appearing in my list type. Okay, so both would be referencing to this object. So let us see the output of this particular function. So you will be having B is equal to 3 because B got incremented. Fn list will be 3, 4, 5, 6 because we have appended 6. Then you are printing A, so A would be 2 because the changes whatever you have done in B will not be reflected outside. One reason is because B is in local scope. The second is you cannot modify the integer object. Integer objects are immutable. Second, if you see fn list, if you have printed fn list within the function, you are getting 3, 4, 5, 6, but my list is also, the changes are also reflected in my list. So because lists are mutable when you are operated by or modified by its own methods. So list is a class, and this particular class definition contains many methods, and if you are operating the list by its own methods, then the changes which you have done within a function are also reflected outside the function. So that is what is being shown with this example here. So let us focus on a different example. Let me take a different example to show how when you don't operate or when you operate on methods which are not part of list class, how does it behave? So let us take this example. Once again, you have a list append function and there are certain instructions which are outside the function. So I am invoking or I'm creating a list called as my list 1 which has 3, 4, 5, which means that my list 1 is referencing to the list object starting value of the list, which is 3. My list 2 is referencing to the starting value of the list, which is 6. Now I'm calling the list append operation or the list append function, and I'm passing my list 1 and my list 2 as arguments. So fnlist1 and fnlist2 also will reference respectively to mylist1 and mylist2. So this is what you see it. So fnlist1 and mylist1 are referencing to 345 with this particular ID, and you are doing fnlist1, you are appending 6 to fnlist1 within this function, which means as append is an internal method of list class, fnlist1 would be modified to 3456. So as we have seen earlier, the changes are also reflected outside the function. So mylist1 will also be referencing to the same object with the changes, all the changes. As you can see here, both these are having the same ID, which means that the same object is getting modified or being appended. Okay, let us see what happens when you operate on methods which are not part of list class. So let me take this fnlist2, both mylist2 and fnlist2 would be referencing to this list or the starting value of the list, which is 6. Now let us see how it behaves when I manually concatenate a particular value to this list. So I'm taking a single valued list which contains value 9 and I'm concatenating to fnlist2. So when I concatenate to fnlist2 gets appended with 9, and when I print fnlist2 we can see that changes, as you can see here. But this change, whatever you have done, will not be reflected outside because this is not an internal method of list class. So when you print mylist2 outside the function, what you get is 6, 7, 8, but you don't get the 9. So important thing to note, or the difference between the top and bottom example, is objects of list class are mutable when modified by its methods. Here I am using the append operation. So append is a internal list method which is defined in list class. So the changes are reflected both inside and outside the function, or outside the function. Whereas here the append I am doing with this plus operation. Plus does concatenation when it is being given between strings or lists. So that change is reflected within the function, but outside the function that change is not reflected. So mylist2 is still having 6, 7, 8. An important thing to note is the ID of fnlist2 also got changed. So it is no more referencing it to the same ID. So whereas in the previous case they are both having the same ID. So this is an important difference. So let us take another example. Till now we have seen examples with list objects and integer objects. Let us take a custom objects which are created or instantiated from the class definition written by you. So let us take this example. Count is a class and this is an initializer function where you have one argument, keyword argument, which is count is equal to 0. So by default count is 0. So you have a main function which invokes this class count with no arguments. So if you don't give any arguments, it takes the default argument which is defined in the class. So C is an object of class count, and when you print the value of C, of course you are going to get the default value which is 0. So now I have a function, I am calling a function within this main function. So M is a function and I am passing C as an argument. As you know, C is an object of class count and I am passing that as an argument to the function M. So once you go into the function, you can see here C.count is equal to C.count plus 1. So I have incremented C, the variable, the attribute of C, which is count. So C.count value increases. So Since this is a custom class, and I have discussed that custom classes are, or custom objects created from the custom classes are mutable, the changes which you have done here would be reflected even outside the function. So if you print c dot count, if you see these, you will see the change or the value get incremented to 1. But we are also doing another operation, which is c is equal to count of 5. So I'm once again invoking or calling the count class to instantiate an object c. So this is a new constructor where I'm using c. C is the new object of class count, which holds value or which holds value 5 to its attribute. So now when I print, so c dot count contains 5, but this change will not be reflected outside because the scope of c is local, and therefore whatever change you have done to c or will not be reflected outside. In fact, c would be referencing it to a different object. So when you print after the function, when you print c, what you see is you will see 1 because you made the change where you have made change to immutable objects and the changes are reflected outside the function. But this has very local scope. So it just print 5 here, but it will not print 5 here. So let us see the output. So first it has printed 0. Obviously, count inside function is 5, yes, because it takes the latest instruction. It will not follow these, but the latest one is this. But this c has a local scope. So count after function is 1. So what is the conclusion? The conclusion is incrementing c dot count inside function reflects the changes outside function, as custom objects are mutable. So c is a custom objects of class count. So this count is the class definition written by you. So the objects which are instantiated from the class are mutable, and therefore whatever change you do within the function are also reflected outside the function. Okay, and this particular invocation or constructed statement creates an object, new object, which is also named as, or the c is referencing to that object, which holds value 5, and but it has a local scope. So this is the second conclusion. C is equal to count 5 creates a new object and has a local scope. So that is how the custom objects behave, friends. I hope you have understood this topic. Yeah. Thank you.